Okay, so in this video, we're going to look at the different kinds of transformations that we use in our course. There are others like rotations or reflections from different positions, but the three main ones we're looking at are dilations from each axis. And that is when you multiply the X or the Y value by some number, A. That's not 1. If it's 1, nothing happens. But if you multiply it by some other number, you'll end up with some kind of dilation. The reflections are where you multiply the X or the Y value by -1. So it changes the value, but only in terms of the symbol. And again, that will change depending which axis you're going along. And the translations are parallel to axes, and that is where you add or subtract some value, C, D, whatever letter you see in equations. Usually it's C for horizontal and D for vertical, but some value is being added or subtracted to or from the X and Y values, depending which way we're going. So let's see how it works. Let's look at dilations first. Now, dilations from the Y-axis, what it means is you take a coordinate like the one I have here, which is at the point 1, 3, and I stretch it out or I push it in, because going from the Y-axis. Now, when it says from the Y-axis, it doesn't mean it can't go towards it. We're just talking about what happens if I multiply it by a number bigger than 1. So if I multiply by something bigger than 1, it stretches it out. If it's between 0 and 1, it'll squish it in. So let's give it a go by applying a dilation factor of 2 from the Y-axis. I'm going to do that to this yellow point here. So dilation of factor 2 from this axis means I multiply the X value by 2. So this coordinate here would be transformed to the coordinate 2, 3, because I've times the X value by 2. If instead of times it by 4, this coordinate would move out to become 4, 3. Whatever your dilation factor is, the number, that is what you're going to multiply your X value by. And see how it moved away from the axis. Let's do the same thing, but with the green one. So let's do a dilation of factor 1/2 from the Y-axis. So 1/2 from the Y-axis means I'm going to multiply the X value by 1/2. So X value here, we have the coordinate -4, 2. So we times this -4 by 1/2, and it brings the coordinate into here. Notice how the Y value hasn't changed, it's just the X value, and you multiply it by the factor. So we still say it's from the Y-axis, even though it squishes it. We're talking about, you add a number bigger than 1, what's going to happen? It's going to pull it away. I've just happened to use a number less than 1 in this case. Now, dilations from the X-axis work similarly, but we're changing the Y value, because from the X-axis means I'm pulling it up and down. I'm not moving it sideways, just up and down, which means it is affecting the Y value. So this time I'm going to do dilation factor of 4 from the X-axis. And that means I'm going to multiply Y value by 4. So the coordinate here we can see is 2, 1. And I multiply the Y value, which pulls it up to the coordinate 2, 4. And I can do the same thing with the green coordinate over there. We've got dilation of factor, let's do 1/3, just to avoid fractions. We're doing it from the X-axis, means I'm multiplying the Y value by 1/3. So the coordinate here is -4, -3. If I multiply the Y value by 1/3, this one here by 1/3, you get -1. So it gets transformed, sorry, -4, -1 gets transformed that way. They're your dilations. Now, of course, if you're doing a whole graph, every single coordinate on the graph is affected in the same way. So the whole graph will be shifted, not just one particular value, but every coordinate on the graph. Now, in terms of an equation, from the y-axis, you will see it appear like this in your equation. This would be a dilation factor of A from the y-axis. Now, I know it feels weird that it says divided by A, but that is important, and go to the transformations videos to see that appear. In this other one though, to end up with from the x-axis, the factor of A is actually just out the front. That is dilation factor of A from the x-axis. That's where you'll see it. All right, let's move to reflections. Reflections around the y-axis just means you multiply the y value, sorry, the x value, I should say, the x value by -1. Because this thing here, the y-axis is becoming our mirror, it's just reflecting it across like that, which means this coordinate of 1, 1 will end up being the coordinate -1, 1. This yellow line is our mirror. And same with the green one. The green one that was at -4, 2 becomes +4, 2. It's multiplying by -1. And I've just realized that for some reason I decided that coordinate was 1. It should be 3. Sorry to those playing at home going, what are you doing? That is around the y-axis. Now, in an equation, in a function, when you see it written, that'll be f of -x. So you're replacing the x with a -x. All the x values are being changed by a negative. Now over here, we're going to multiply all your y values by -1. So this coordinate two positive ones, sorry. We're going to use this line here. The x-axis is our mirror, and it gets reflected down and becomes 2, -1, like that. And the green one that was at -4, -3 now gets multiplied by -1 up to there. So the x value does not change. It's just the y value that has changed. Now, in terms of the equation, that is where a negative appears at the front of the equation and flips the whole thing. That's reflections. Last one, let's do translations parallel to the, or to the y-axis, is a vertical translation. And parallel to the x-axis is a horizontal translation. That should make it fairly clear because parallel to the x-axis, it's going that way. And the other one is vertically. So if I'm doing vertical translation, this one, when it talks about the y-axis, is the only one that actually affects the y value. The other ones all affect the x values. So in this case here, for the translation, I'm going to add or subtract the value of c, or whatever it might be, from or to, add to it from, or subtract from the y value. So in this case, I'm going to do translation of, vertical translation of 2 units down. So 2 down. So what I do, I take the coordinate that was at 1, 3, and that now becomes 1, 1. I've subtracted 2 from the y value. And now let's do a vertical translation of 3 units up. A translation parallel to the y-axis, or 3 units up. So the coordinate that's at -4, 2 now goes up to -4, 5, like that. In terms of an equation, that's where you have an equation and then you chuck a plus C, D, A, doesn't really matter at the end. I should probably put a D to be consistent with how you see a lot of equations. And that's where you have vertical translation of D units. Now, if D is positive, it'll go up. If D is negative, it'll go down. Last one. This is where you affect the X value. So if I do a horizontal translation of 5 units left, it means I subtract 5 from the X value. So the coordinate here is 2, 1. That then becomes -3, 1. So we subtract 5 and you get down to there. The green one, I'm going to do a horizontal translation of, let's do 6 units right. Doesn't matter how many go right. I'm going to add 6 to the X value. So the X value here was -4, the Y value was -2. The coordinate now moves all the way over here and becomes 2, -2. Notice the Y value has not changed, it is just the X value. Now in an equation, you'll see horizontal translation, let's say of C units, because C is often used, or H sometimes. In an equation, you would see it like this, X minus C. Okay, so if C is positive, you're going to the right. If C is negative, you're going to the left. Now, when you say C positive, that means you'll see f of x minus 1. That means to the right 1. And f of x plus 1 means to the left 1. Because if you put a positive number there, you'll still have the minus symbol. But if you put a negative number there, the negative will cancel with the minus and it'll go the other way. And that is the effect of a dilation, reflection, translation on a single point, which would apply to a whole graph with all the coordinates. I hope that makes some sense.